Let's start. Hello everyone. My name is Silvia Misk. I'm a mining consultant at Jovariances, and here with me I have also Artur Endlein, that is a data science consultant at GV. Hello, Artur.
Hello, Silvia. Hello, everyone. Good afternoon.
Good afternoon. So today I'm going to show the webinar of how to expand the Isatis.neo capabilities with Python scripting. So I'm going to show some practical examples. So the presentation will last about half an hour, and your microphone is in mute, so I will answer your questions at the end of the webinar. So there is a dedicated part of the webinar too, where you can type the questions if you want, so I can answer at the end. And we will also receive a copy of this webinar probably tomorrow. So let's start. So we can do a lot of Python. I guess that most of you have heard about Python, which is a programming language that is, I can't say that it's easy, but I think it's one of the most easiest programming language that we have, where we have like multiple libraries. And there is a lot of tutorials on how to program in Python. And today I will focus on how we can expand the Isatis.neo capabilities using the Python script on the batch files and on the calculators. So today I'm going to show 4 examples. So the first one is how to automate estimation from parameters in a CSV or Excel file. So the idea here is to have all the parameters for the search neighborhood to run a clean or invest distance. And then I will automate the routing using the parameters in this table to be used in Isatis.neo. Then the second example will be to print the statistics from different data tables to CSV. So this different data table could be, for example, the data from drill holes, and then from data from block models, and then I will print the summary statistics in a single table, maybe, for example, to do the validations and to compare the mean, the minimum, the maximum value between these two data tables. The third example will be to do some simulation post-processing. So I will show you how can enhance the use of the simulation that we can do in Isatis.neo, doing some post-processing using this Python scripting. And finally, I will show you how can we customize EDA plots using matplotlib libraries to create different graphics. So before we start, you should know that in Isatis.neo, there is 2 ways to use the Python scripts. So the first one is by the Python calculator that gives you access to the Isatis.neo project database. So we have on Isatis.neo this tool that is the Python calculator, where we can implement some Python scripts to run some summary statistics, post-processing of the simulation. We can also create some tables. So there are a lot of things that we can do using this Python calculator, where we can have direct access to the Isatis.neo project database. And using the Python scripting, you can do a lot of things. So it's very useful that. And also the second way is also to put some Python blocks into the batch files. The batch file is the scripting inside Isatis. So the idea of the batch file is to record or to automatize all the resource estimation routing, and then we can enhance or improve the use of the batch files using this block Python between the tasks of the Isatis.neo batch files. So I will give you some examples, and I think will be clear for you that these two ways that we can implementing the Python scripting into Isatis.neo. So the first example, so how to automated the estimation from parameters in CSV and Excel file. So this first example, it's very useful. We used a lot in our consultancy service here. So here we have, for example, one problem. So the one thing that is very useful in Isatis.neo is this batch files that, as I said, the idea is to automatize the routine, and then using these batch files, we can implement some looping. So we can do some loopings from different domains, different variables, different deep. So I can say that the easiest way, the simplest way to implement that is to define different arrays for your different parameters in the batch files. But the problem here is that when we create different arrays, for example, the array of the variables where I will loop on the iron, aluminum, magnesium, and the methods where I will run for the iron, the ordinary Krieg, and then for the aluminum and manganese invest distance. When we declare the parameters that we need to loop at using these arrays, when we look at the first column, it's okay because everything is aligned. But if we look like further, imagine that we have like many variables or many domains. It will be very complicated. It's not clear like what are the parameters of the magnesium here. It's not clear to see because the columns here are not aligned. So if you want to change, no, now I don't want to estimate the magnesium using a dip of 0, I will change that. So it's a bit tricky to manage that using these arrays because the columns are not aligned. So the more convenient way would be to declare the parameters using the CSV file, where we have where it's easy to read and to edit. So everything is here in the table. It's easier to see the parameters, to change that. So it's more convenient. But how can we use these parameters here in the CSV table to be declared in the Isatis.neo and run a loop on that? So the solution here is this that I'm showing. So here I have a screenshot of the batch file. So here we can see the task of Krieg. So this is the task to run the ordinary Krieg. And then the first thing, we import the pandas library. And then using the panda libraries, I will read the CSV. So I have this CSV table where I have all my parameters. And then I read the CSV and create a data frame that I call here data frame search volume parameters, where I have all the parameters that I will use to run the resource estimation. And then using this table, this data frame, I will run a loop in this data frame on the rows of the data frame. So here, this is the way that we implement a loop on Isatis.neo. So I will put 4. This is the index, and then I will start from 0, and then it will I will loop in the rows of this data frame. So as the rows start at 1, the length of the row will be from 1 until the number of the rows that I have, -1, because I'm starting with 0. And then I will set here the parameters for each row using the name of the data frame and the column, the name of the column here. And then here is the way that I will go through the loop from the index of the loop. And then for each interaction of the loop, I will update these parameters according to the loop that I'm implementing here. So it's not complicated to implement, and once you have that, you can run a sensibility analysis, change the parameters in easiest and clear way. So the second example is to print the statistics from different data tables to CSV or Excel format. So what are the problems? So for instance, you run your resource estimation, you have your data and also your estimation, and then you want to validate your estimation, but when you use the statistics tool inside Isatis, it only allows you to have the statistics at one data table at a time. So you will print the statistics in the message window. First of all, you have here the print statistics from your data, and then secondly from your block model. But will be much more convenient if you have a single table where you can see the results from the summary statistics of your point support or your samples, and then your block model. So how we manage to do that? So the solution is, first of all, to create this Python block, as I said at the beginning, inside the batch file. So I initialize here a new CSV file. So here I'm creating this CSV called startvalidation.csv. And then I will create, first of all, just the name of the column. So it's the support, if it's composites, or the block model, the name of the domain in case that I have, I will run into multiple domain, the variables, and here the summary statistics. And then using the batch files, I will loop over the variables in the block model, the support, loading it into the calculator task. So I have here implement the loop, and the first calculator will correspond for example, the summary statistics that I will calculate it in my composite support. The second one will be on the composite using the cluster weight, and then the third step will be in my block model. So how can we implement that? So the solution will be in the batch file, I will loop over the variables in the block model, loading them in the calculator. So here, first of all, I will do the summary statistics using the composites, and then I will do the same, the summary statistics in the block model. And in this case, I will use the whole file mode, where I have access to the whole data table at once, allowing you to calculate the statistics easily and faster with NumPy function. So here is the way that we calculate the summary statistics. So in the calculator task, I will write here, for instance, the count. So will be the length of my variable that I'm writing here. So the length or the number of samples that I have of the ion in the region, and then the minimum value of the ion, and then the maximum, the mean, and the standard deviation. So in the calculator, I can directly use the NumPy library and do the summary statistics. And then at the end, I will append this summary statistics in this stats validation CSV table that I have created here with the right. So I will put these statistics and calculate the summary statistics using this NumPy library. So this is what you will get. So for example, as I show in the first example, I run here the ordinary kriging on the ion. So I will load the composite, the raw composite without the cluster weight, here with the cluster weight, and in the same table I will gather also the estimation results. That is the results of the ion in the block model, and then we can compare here much easily if if we can validate or not the estimation comparing the mean of the data and the block model. So let's go further a little bit more. So we can also use the Python script to do some post-processing of the simulation to run some risk analysis. So the problem, you want to calculate the uncertainty of the grades over the volume of the production. So here, for instance, we have run the simulation of the R using the turn-bands method. And we also gather the blocks into a volume of production, year production. So here I want to calculate the confidence of interval of 90% of the simulation inside this volume production. And then the solution here is to do the post-processing of the simulation using the Python calculator. As I said, the Python calculator, you can directly access the database of the Isatis project. And if you know how to use some NumPy functions or scripting, you can do this simulation post-processing. So here, the confidence of interval of 90% of the simulation. To calculate that, I calculate the quantile of 5, the quantile of 95, and then at the end I will calculate this value using this equation here, which is the difference between the quantile of 95 by 5 divided by the mean multiplied by the mean of the simulation multiplied by 2. And then we end up with the dispersion of the simulation in this support of the year. So I will run here a loop over the year, and at the end I have this risk assessment over the different years that we can group into this deposit. And then finally, we can also customize some EDA plots. So the solution for that is to import the matplotlib into the Python calculator, or we can also do that in the batch files. Both ways we can do that. So we have this type of libraries, that is the matplotlib. There are a lot of examples on how to manage this library to create different plots. So you can just type matplotlib and you can see these examples here. So what we have done, so the solution is to use in the Python calculator the whole file mode where we can access the whole database. We put here the interval of confidence of 90% of the simulation. We have here the mean and also the different volume of production that we have grouped in this deposit. So we have the first year, the second year, until 50 years that we have grouped in this case. So the first thing is just to import this library, the matplotlib as PLT, and also the pandas one, which is the data frame that I show you where we can manipulate data frames. And it's very useful when we deal with tables, Excel tables, for example. And here we create this data frame where the column of the volume correspond to the different years, the different, for each block we have the mean of the simulation and also this confidence of interval of 90% of the simulation. And we will group that, we calculate the mean for each volume. So all the blocks that correspond to the same volume production, we calculate, like we will reblock for each year. And then we create this variable here, V, that corresponds to the index of this data frame that we created using this group by volume. So the index corresponds to the number of the volumes, the years that we have. The mean corresponds to the column of the mean that we have calculated using this reblock here by year. And also we have this risk, this dispersion of the simulation for each year. And then using the matplotlib, that is like we assess that using the PLT, and then we have this function. So here we'll plot the V that will be in the horizontal axis. For each volume, we will have the mean of the simulation, and we will plot this graphic in black. We put here the titles, and then at the end we will also fill between the volume and the mean the risk for each year, and then we will save this figure. The name that I said is with this name here that I'm creating. And then at the end, we will end up with a figure like that, where for each year we have the mean, which is this line here in black, and also the risk attached to each year we have here in gray. So we can see here that we have some years where the dispersion of the grades is high, and where in other years we have the dispersion of the grade it's very low. So the risk of the grades that we are reporting here is lower than in this case here. So this study is very useful. You can I'm running this study in a year volume of production, but we also can do this in some stopes or mine planning to see what would be the risk of the forecast mine planning that we are having. So it's it can be very helpful, especially when we want to get a better reconciliation. So now I will just show you quickly how we can do this in Isatis.neo. If you want, there is some trainings where we can go deeper on this Python script on Isatis.neo and also on the batch files. So let me just open here. So this is the Isatis.neo. I won't go further on that. If you want, you can send me an email and then I can do some demo for you, showing how we can use Isatis.neo, implement the kriging, and show the tools that we have available so far. So here on the top, we have all the tools that are organized by the usage, so data management, statistics, interpolation. So we have many tools here. We have here the data tree where we can see all the data of our project. And here we are on the 3D viewer where I'm displaying here the volume production of the year. So we have more than 15 years blocks that are grouped here. And let me show you here how we can manage. And here we have the batch file. So every time that we are running some studies, we can record that task, and then all the routine, the estimation will be recorded here. So it's very it's very easy to use, and it's very handy because you can record everything, and once you have new data available, you just have to rerun your scripting. Of course, check your parameters, but the macro of your routine will be recorded here. So it's very, very useful. And now with the Python script, we can take advantage of that even more. So here I'm going to show you the first two examples that I said. So the first one that was to run estimation using the parameters from an Excel table. So the first thing that we usually do is just to import here I import the data, I import the pandas library, because this, as I said, this library, it's very useful to deal with data tables. So using this panda library, I can read the CSV where I have all the parameters and create this data frame. And then secondly, I will loop over the rows of this data frame. And then if the column method is equal ordinary kriging, I will run ordinary kriging, or if it's equal invest distance, I will run the invest distance, of course. And then I will loop over the rows of the data frame. And then for each interaction, I mean for each line, I will update the parameters according to what we have in each line. And then we run like that, and then we just update. So here is deep, so I have to put the $sign, parentheses, data frame, TF, search volume parameters, which is the name of the data frame that I imported here at the beginning, and then the name of the column where I would like to replace or to update the values here, so it's the deep, and then I will run through, I will update that for each parameters running this loop. And then I have here the interpolation. So here I just have to run. And then I run here the ordinary kriging for the ion with the parameters that are set on the table, and also the invest distance. Just before I start, there is a shortcut. If I press Ctrl E, I have access to the folder of my project. And here, just to show you, we have in the public folder a folder called parameters, where I have here the search volume parameters that I said. So this was the folder where I gather all the parameters that I need to run a looping, which is the method, the orientation, and also the size of the search neighborhood. And then here on the estimation validation, it's where I will loop over also the search volume, like the data frame that I created. And for each interaction, I will first of all, let me just, let me show you this because it's a bit. So this one is just to calculate, as I said, the length, the number of samples, the minimum, the max, the summary statistic of the ion without the clustering weight. This is with the clustering weight, and this is to have the summary statistics of the block model. And then if I look over here, at the end, I will have the results. This stats validation, which is the table that I just created, where I gather all the summary statistics in one shot. And then finally, we have here the simulation post-processing. So the first thing I create here, the variable, there is the interval of confidence of 90% of the simulation in this volume production of the year. In this case, I reblock the blocks over this production volume. And yeah, I duplicated, and I have here 50 volume production. So for each volume production, I will calculate the interval of confidence of the simulations. So here I have for each year, I will loop over each year. I will calculate this interval of confidence, that is the V3 here. And finally, once I have calculated the interval of confidence of 90% of the simulation over this volume production, I will create this data frame, as I said, calculate the number of volumes, the mean for each volume and the interval confidence, and I will plot this value here. I will create a plot using these variables that I create, and at the end, I will create this figure on here just to show you, and I've just created this interval of confidence where we can see here, for instance, that these volumes here and here in particular, the risk is high because the precision of the simulation is much higher than here. So probably if we mine here, we will need more drill holes in order to decrease this dispersion, the risk attaches to the grade for this volume production. So this is just a few examples where we can enhance the usage of Isatis.neo using these Python codes. This is just the first webinar. The idea is to present at least 3 webinars. So this is the most usage Python scripting that we have. The idea is to, in the second one, to show you more advanced things that we can do. So Artur used a lot of Python scripting to, for example, to use some machine learning. So we can do a lot of things. So we will do the second webinar showing more advanced. And probably the third one will be to show you more things that we can do. We are developing different ways to use the Python codes, not only just on the Python calculator and the batch files, but we will show you more interested ways to use the Python codes as well. So pay attention because we will have these 3 webinars in the sequence. So let me just come back here on the demo. So GeoVariance is in few words. So who we are? So GeoVariance is a global provider of geostatistics based solution, and we are market leader in reference on that. We were founded in 1986. We have more than 35 years of expertise in geostatistics and software development. We are more than 30 technical experts. That includes consultant and software developers. And we also are a pioneer in advanced geostatistics, and we have a partnership with the Center of Geostatistics, that is the Mines Partech. Our main office is in France, in Fontainebleau, but we also have offices in Brazil, in Belo Horizonte, in Chile, in Toronto, and also in Australia. So those are the trainings. So if you want to learn a little bit more about the Isatis.neo scripting, we have some upcoming sections that is in September, in Paris time, in October, in Perth time, and also we have more too in November. And also, if you want, we can have some on-demand sections. So just we can just contact us, and then we can show you. Besides this training, we also have other trainings in applied geostatistics, nonlinear, linear. So we have plenty of trainings, and also we offer some consulting services. So we can help to build your Python and batch file scripts, and also do other type of services as well. So our next webinar will be in November. So discover some of the powerful workflows implementing batch files and Python scripting we have built in for our clients. So will be the advanced webinar where we can show you some examples, real examples that we have built. So any questions? Let me see here if there is any.
We have two questions, one from patient Kanaku, which has left unfortunately, but his question was about the recordings, and as you said, you will all receive those recordings at the probably tomorrow.
Yes.
And Ian Crundle asked if these batch files are available to download to review the key steps in the process. I believe that we can share.
Yeah, no, for sure.
Examples.
Yeah, if you sorry,
yes.
you can. Sorry, Artur. You can say. I was just going to say that we can share. I think there is no problem.
Yes, and you can email us in any case.
Exactly. I don't know if I have our emails at the end, but I can type here for. Oh my God! I just have the. Let me.
You can always ask David, but it's our consultant in Australia, so it would probably be better to contact us directly.
So
but
my mail
while Silvia corrects this. In case anyone wants to do some more advanced tests on plotting inside the calculator, if you are more advanced in Python, I would just suggest not to try to use the, you're missing an I, it's Endlein. Don't use the interactive plotting of Matplotlib inside the calculator. It might crash. But you can use that outside in the Python block. But please go ahead and try. It's extremely powerful. We've been doing some very unexpected and interesting things using Python and Isatis, and it's been helping us a lot in developing our work.
Yeah. I bet you will like to see what Artur is doing in the next webinar. It's very interesting for sure. So I think there is any other question. If no, I will end this webinar. Okay. So thank you very much for your time. Don't hesitate to contact us if you want. So that's it. Have a nice day. Bye.
Thanks, everyone. Bye-bye.